Hi Peel Drone, another video today. The ZMR250 version 2 frame from FPV model. Very tough frame, very strong carbon fiber of course. Arms are 4 mm thick, that's extensive. A lot of screws to hold down the main frame to the arms. Biggest thing on it, PCB. Pretty much full one, actually designed mainly to cater for Naze32 boards with the extra traces and connections here to minimize the clutter and the wiring on the board. So let's go through the build here. Motors picked up from Rotor Geeks, Cobra 2204 2300 kV. Great strong motors. ESCs are DYS SN20A or BL20A. I went with a 20 amp. You can always opt to go with a 30 amp if you're gonna put a lot of load on those motors. For example, if you're planning on using 60-45 props, I would advise that you go straight to the DYS 30 amp ESCs or any, matter of fact. Board, Naze32. This is a full board. I don't really intend on using GPS, but that's what I had at this point. Receiver is a Spectrum DSMX carbon satellite receiver wired to the Naze, again through the great serial RX connection. That's for the receiver. I do have at the bottom here a little like powered tiny microphone. I just do like to fly with audio also. Camera wise, PZ600 mini. That's a 25mm by 25mm, I believe. CCD, Sony CCD receiver, sorry, sensor. Then the other thing that I added here yesterday, I just got from Hobby King, is the Minim OSD Micro. This is the smallest so far. As you can see, it's very tiny. $12 US. I mean, it's a bargain. I just toasted actually one while I was playing with it, trying different firmwares. This is running MW or multi-Wii OSD firmware 1.4.1R, I believe. The next thing, I did add a servo to take advantage of the Naze32 onboard gimbal controller. So this is the top plate. I do have my transmitter here, which is a BOS 350 Boss Cam 350 milliwatt. Here's the servo I added. I found this servo laying around here. I thought I'd just give it a use. So I do have manual control over the camera's movement, and I can activate the gimbal where it actually reacts to tilts back and forward. Camera, secondary camera, or let's say the recording camera, is a Mobius. This one has been decased, and I also did remove the LiPo from it. A lot of weight that you don't really need, as you can power the camera through 5V here from the PCB board, which has a built-in 5V BEC. So you can just power that and save yourself a lot of weight. Buzzer didn't come with it. I just soldered this. Capacitors, I always add capacitor to most of the lines just to smooth things out a little bit. One more thing you will see here, there is a 3-pin, and if you look here, you'll see says REG. That's a regulator. If you want to add, let's say, a regulator, a voltage regulator that would drop any voltage to 12, let's say if you've decided to fly 4S, that will drop the power or the voltage down to whatever you set it up to. so you can feed your camera and transmitter. In this case, this camera can handle, I believe, up to 17 volt, and the transmitter can handle up to 24 volts, I believe. So I'm good for that. I did, though, experiment with some homemade LC filter. Wasn't bad. Was okay. And also with a regulator, dropping the voltage actually to close to 9 volts. So both work fine as is. I don't really have much of a problem on the video feed. Adding those things would definitely make things a little bit better. But if you have a big issue, I totally advise with going with an LC filter or a regulator, which again drops the volt, might help a little bit. Okay, we're back assembled, and we'll just fire her up and see what it is. Three things I connect when I put the top plate back: servo horn, the servo wire, and the transmitter wire. Just to make it a bit simple if you need to service the frame or the board later on. So I have a little screen here, and I'm just gonna turn this on. We'll look at the OSD and the gimbal feature. So radio's on. I'll just power that up. And the screen. So as you can see now, I get the OSD info. I had it only set up for voltage, which reads the voltage off the Naze32 actually, so you don't need to wire the 12 volt directly into your OSD. Flight time on the right here. I have the horizon, and I also have the compass on the top. So I'll show you another cool feature that it has. Once you're turned, like your system is up, and then what you could do is, let me just get that here. Okay, and just line it up. So what you could do when you're disarmed, of course, you could use your sticks going throttle mid, then yaw right, and then full pitch. And once you do that, here's what you get here. This is your PID numbers of your Naze32, where you can actually, using the sticks up and down and right and left, you can actually change your PIDs, which is an awesome thing, considering you're flying or you're racing and then there's a bit more wind, less wind or whatever, and then you need to adjust that between flights. All you need to do is just do the stick combination and increase something or decrease something and see how it affects your flying. Great feature, great OSD. Again, I just can't say enough for $12 thanks to the open source world here. Last thing is the gimbal. You can either control your camera manually. You can assign a switch that you could control it manually, or you can just hit another switch here on the radio. You program it, and then this is the gimbal feature is on, so your camera moves, adjusts for the tilt here. Of course, you can play with the ranges and like the travel extent and everything. Once you're done, you just hit that. That's pretty much the build that I'm reviewing. I hope you guys enjoy this. If you do, please like and subscribe, or join us at our group. Search us on Facebook. It's Peel Drone Society. Thank you, and have a great day.